So first thing I will do is that I will, sorry, I just, it can be both fungible token or non-fungible token. It depends, you can design that into both kinds of it. It depends on how we do it. And the first thing I would do is that I'm gonna send you a link to a repo that I already made. I will put this link in the chat box. So here, so if you have a computer with you, you can open this link and you can see some coding here. So this is a very simple demo based on using Algorand JavaScript SDK and also using React. This is built with create a React app. If you are familiar with React, then it'll be good. And if you're not familiar with it, it's also okay, because the code we are gonna use is mainly the code that is related to Algorand is mainly this part. So open this folder utility and algo.js. You will find this file in this path. And here has all the functions that I'm gonna work through today. I'll explain all of these codes line by line to you, and you understand how to develop an application. And then I will introduce to you how to integrate this into a React demo. But before that, I will give you some time to open this page and to have all of this code with you. And before we jump into the coding part, I first need to introduce some basic terms and concepts to you. Here are some of the general concepts that all of the blockchain has, but in the case of Algorand, it has a little bit different meaning. And these three concepts are Algorand specific terms, and I will also explain this. So let's go through this one by one. So first, account address. So a blockchain is basically a database that stores data about the balance of each account, how many tokens that each account have. And they can also store some arbitrary data under each of the accounts. And each account will have a public key, a private key, and an address. And the address is actually derived from the public key. And on Algorand, there are three kinds of accounts. The first one is a normal account, just like any account that you know, maybe on Ethereum or Bitcoin. This account holds the balance of tokens. And also we have multi-sig account. So this account is still just like normal account. It holds a balance of tokens, but this account is controlled by multiple private keys and public keys. So you have a multi-signature function with this multi-sig account. And also we have a logic account. So this is actually built from the smart contract. And this is account that is controlled by logics instead of private keys. If you want to spend tokens out of this logic account, then you need to send a transaction that meets the logic of this logic account. So this is the concept of account address. And also we have transactions. The transactions on Algorand are used for transferring algo tokens or transfer customized assets tokens, ASA. And also you can use the transactions to get registered to participate in the consensus protocol. So if you want to participate in the Algorand consensus protocol, there's a pre-step, which is that you need to send a transaction to the network to let the network know that you're ready to participate in the consensus protocol. So this is a special kind of transaction. And node. The nodes in Algorand can be configured as different kinds of nodes. So it can be relay nodes or non-relay nodes. Relay nodes means that you will be taking on the job of relaying the messages to all the other nodes, or you can choose to be a non-relay node, which means that you only need to connect with the relay node to receive and send messages to this relay node, and you don't need to receive and send messages from all the other nodes. In this case, you can save your bandwidth. Just in the case that you don't want to just spend too much bandwidth in the network, then you don't have to be a relay node. And also you can be participation node or non-participation node. And participation here actually means if you want to participate in the consensus process. If you are participating in the consensus, then you are a participation node. And if you're not, then you are a non-participation node. And also you can choose to be archive node or indexer node. So archive node will let you store all the history of the blockchain from the initial block, the first block of the blockchain, to the latest block of the blockchain. You will have all the data stored on your node. And this may take a lot of data storage in your computer device. And if you don't want to spend too much storage on running a node, you can choose to run it under the indexer node, which will only let you store the recent 1,000 node in your local computer. And this will save your storage cost a lot. So these are the general concepts of the blockchain and in the context of Algorand. And also we have some different things about Algorand. So we have Algorand standard assets. So this is a standard that lets you to issue your customized tokens, kind of like the ERC20 tokens. And I will introduce you how to do this, how to issue the token and how to transfer the token. And also we have atomic transfers. And this is basically to pack multiple transactions into a transaction group and send this transaction group to the blockchain to be executed at the same time. So these transactions, you can see them, they say that they have the atomicity with them. And also we have the smart contract. And this is where you enable fund management, token management, token transactions with predefined logics. So this is a part that to make your application smart, intelligent. So these are the terms and concepts you need to know before we jump in the coding part. And so first, let's see a GUI demo. So this demo is actually built on using this repo, the code in this repo. So you can clone this repo in your local computer, and then you can you need to install Yarn, or I'm using Yarn for this project, so you better use Yarn if you can just let me just quickly show. For this project, I use Yarn, but you can also build this using npm, I guess. But you need to replace the the package manager. And you just use this command to see a preview. And after you do this, you can see a demo like this in your local host. And this has all the basic functions of Algorand. You can create an account here. Just click on this button and it will generate an account for you, and which contains an address and also the mnemonic of your, and this actually stands for your private key for your account. And also you can go to our, so this demo is based on our testnet. It's not a mainnet. So you can just feel free to use it. If you want to have some test tokens, you can click on this fund account and it bring you to our testnet faucet. And here you can input your address. Sorry that my network connection is not really good these days. There might be some problems during the demo, but hope you guys can understand. Okay, so here it is. You can, there should be a Google reCAPTCHA here. Just, okay, let's wait for a while for its loading. And also we have the other functions like sending transactions. And by sending a transaction, you can either create an asset. So here you can input all the parameters of this asset you wanna issue, the name of the asset, the unit name, and the URL of the assets. And here are some of the roles that you can you can configure. A manager is an address that so this address will have the power to change the configuration of this asset. It can change all of these following configurations. And the reserve address is the address that will hold all of the tokens, asset tokens, after this asset is issued. So if you issue an address and you set the reserve address to be this, then all the token will go to this address account. And this address will be able to have use the private key to send all these assets around. And also you can specify address to freeze this kind of asset. You can freeze all of the transactions related to this asset using the private key of this account. And also there's a address that you can use to revoke this kind of asset, and you can revoke all of the assets of this under these assets, and no matter where are the assets, how many tokens does each what account has, you can always revoke all the assets using the private key of this account. And okay, here is the dispenser. So I have created an account here, and I suggest you to do this as well. Just create an account and put your address in here, and go through this recaptcha and put your address here, click dispense, and you send a request to the blockchain. And as you can see, here is a transaction ID. And then you can go to our Explorer. The address is algoexplorer.io. So yeah, let me put it here. Sorry, my network is a little bit slower these days for some reason. And then you need to switch. So this is the mainnet. You need to switch to testnet to say this transaction has been on the testnet. Okay. And then just enter the transaction ID from here to here in the search bar, and click on the transaction, do the search, and it brings you to the transaction you just requested. And then you can see that you requested some tokens to this address, and this is your address, and you can see that this address now will have some tokens, some token algo balance. You have 100 algos, and this should be enough for most of the applications. And also, apart from creating an asset, you can also send a payment transaction. For example, you can send sorry. So this is an account that I already have. You can use this as well. So this account already has some algos. You can send some algos from this account to this address, and also please pay attention that this amount is actually in macro algos. So we have 6 decimals for the algo unit. So this is actually 1, 2, 3, 4, 5, 6, 7 actually stands for 1.2345667. So you can click on send transaction, and it will send the transaction out. And this usually takes 5 seconds to finish the transaction, but depending on your network situation, it could be slower or it could be quicker. And if you open the developer portal, developer tool, you can see there should be some messages here. I think it's not working correctly. Let me try it again. Yeah, network is not really good. Okay, it shows up. So it's waiting for the transaction confirmation, and this should be done in 5 seconds. Okay, the transaction is confirmed. And then you can just copy and paste the transaction ID into the Explorer. So yeah, here is the transaction. So you can see that this is address of this account, of this mnemonic account, and this is the receiver, this B7K. This is the receiver, and it sends 1.25567 to this account. And also you can send ASA transactions. So here, maybe I can send maybe 100, send the transaction. And should be, should take, okay, the transaction is confirmed, and you can see that in the, or you can also click here to bring you to the transaction directly. So this asset ID is actually a USDT token I made, and as you can see, the asset ID is here. You can click into this asset ID to see the asset information, and as you can see that it sends 1 USDT from this address to its home. So here, this is the address, and this is actually the mnemonic of this address. And the asset ID shows, clicking the asset ID shows the information about this asset. It has this amount of asset in circulating, and this has this amount of total supply, unit name, ID, creator address, reserve address, things like this. And at last, we have a smart contract-based example. So this example is called limit order. It is actually a contract template that we have on our developer website. So what it does is that it creates it actually facilitates in the asset trading. So let's say if you want to trade 100 assets in exchange for this amount of algos in micro algos, then what you can do is that you can create an order in the marketplace. Let's say we create an order like this. Click on create order. Then in the order book, you can see that there's order. Order ID is 0, asset ID is this, and you want to exchange this amount of algo in exchange for this amount of asset. And here is a contract address. And after you have this order, you can also send another transaction to take this order. And here, this transaction actually contains 2 parts. One is to transfer the algo from maybe Alice to Bob, and the other transaction is to transfer the asset from Bob to Alice. And this all happens as a transaction group, an atomic transfer transaction group I mentioned before. And there will be 2 transactions involved in this process. And if you click on the send transactions, you can see that this will happen in, so this is actually, I don't know what it is actually. This would be a contract code, I guess. So waiting for the transaction to be confirmed. Okay, it's confirmed. And if you click in, you can see that this transaction, this is supposed to be 2 transactions, and one is from the contract to the address, and the other one is from one. Oh, sorry. Let me try to search it. Okay. So here you can see that this is a transaction that involves the smart contract, and the contract code is here. This is the contract using our programming language TEAL, and it is a stack-based language. I will introduce this later in detail. And if you compile this code, you will get a bad code like this. This is a base 64 encoded string, and also you will get an address, and the address of this contract is this one. So this contract send this amount of algo to this receiver, and if you click into this receiver's account, you will see that it not only receives this amount of algo, it also automatically sends this amount of asset, USDT asset, to another address. And this is the receiver of this address. And this address is actually the creator of this contract. So I will introduce the flow of this this example in detail in the later session. So here, after we see this GUI demo, let's start coding. The first thing you need to do is to set up the development environment, and to do that, there are 4 steps. So let me open a sorry. Let me open my it's not working. Let me try to just maybe create what is going on? Okay, I have to open it from the, where's my terminal? Okay, so here's my terminal. So what I'm gonna do is I wanna create a folder named maybe Algo, and I want to get in this folder and open my VS Code from it. Where's my VS Code? Okay, maybe just open folder. So somehow my shortcuts doesn't work. I don't know why, but oh, okay, here's it. It's on another screen. Sorry. So here is an empty folder, and I need to create two files. The first one is I will name it Algorand.js. So this will be the file that contains all the functions that interact with Algorand blockchain. Functions that interact with Algorand blockchain. And also I will create a main function, main.js, and this will has this will be the testing. This will be the playground. I will do the testing in this file. Okay, and after you have this folder, the first thing you need to do is that you need to have Node.js, because we are going to run the file through the command line first. So you need to have your Node installed. You can check it with this command node-v, and it's if it returns you with a version of a node, then it means you have installed your node. And the second thing that you need to get an API key from a company named PureStake. So PureStake is it's kind of like the Infura for Ethereum. So it provides you with an endpoint to connect to the blockchain, Algorand blockchain network. And if you have your own node on your blockchain on your computer, then you can also connect to that node. But usually, that running a node is pretty cumbersome for just the developing application. And in that case, you can just go to this website to request for an API key, and also the API endpoint to interact with the blockchain. This is also pretty slow. Okay, and just you can register for free, and you will get an API key after you have registered. And here I will just use my own API key. I will copy and paste it from somewhere. I will also send this to the chat, so you feel free to use this as well. It has the API for the testnet. It also has the API for the mainnet. So you can use it as a production API or the test API. So I will just I already sent my API key and the endpoint to the chat box. So if you don't want to apply one, you can use mine. It's okay. It's for free anyway, so you can use it. And the next thing you want to do is that you want to install the JavaScript SDK to your project. And to do this, you can either use npm or you can use yarn. And I usually prefer yarn, so I will just use it here. And to do that, you just enter this add Algo SDK in the command line. Just hit the enter button, and it will install the Algo SDK for you. Algo is written in Go. not really C++. The SDK, just a little bit more about SDK. We have 4 languages of SDK. If you go to our website, Algorand, if you go to our GitHub, we have the Algorand client is written in Go, and we have SDK in Go, in JavaScript, in Python, in Java. So we have 4 kinds of SDK, and they all have very well documentations. So you can just refer it. And here I will use the JavaScript SDK. So in the README, it has a very brief introduction. And also you can go to our developer portal, which is developer.algorand.org. And you can see that there is a pretty comprehensive documentation regarding all the things you need to know about Algorand. Okay, this is going to take some time. Okay, so you have documentations, which contains all the basic documentations about the Algorand, how to start running a node, what are the features, the reference doc. And also, if you want to get hands-on quickly, then you can go to a tutorial session, which gives you a tons of tutorials on how to do this and how to do that. And you can filter this with languages and the level at how hard it is. And also we have several solutions. So these are the use cases you can build with Algorand and they all have very good documentation to tell you how to do it step by step. And you can just go nuts. And also we have an article section that you can explore some of the new features that we have been building, some of the updates. And also we have a forum. So this is a place where most of our developers go find help. We have a lot of people on here, and you can ask questions on here, and you will know a lot of people will answer you, and we will answer you as well. Just any question you have here, you can just search it here. And if you don't find the questions you don't find your answer, then you can ask your own questions here. Okay, so after you have finished to install your JS SDK, you will see that it has automatically created this node modulars folder for you, and a package JSON and a yarn log file. So these are files for the front end, for the JS SDK. And next thing you need to do is that you need to import the Algo JS SDK. And to do that, what you need to do is to make Algo SDK const that require Algo SDK. Yes. So now you have successfully imported the Algo SDK. And then what you need to do is to create an instance of the Algorand client. So you will access the Algorand network through this instance. I will also send this command into the chat box. And so now you have finished the setting up of the developer environment. And the first thing you want to do is to generate a wallet. And this is also very simple. So I will do this with a function. So I will create a function here called generate wallet. Generate wallet. And here are some of the functions you can use to generate with wallet. So we can have an account, which is Algo SDK. I'm using the SDK here and it has a function called generate account. And here I got an account. And also, if I want to get a mnemonic of this account, I can use a function called secret key to mnemonic. And I just put the account here. And the account actually, it has an address and it has a secret key. I will convert the secret key to mnemonic. And then I return both the account and the mnemonic. Okay. So now I have finished this function, and then I want to export this function to for the main file to use, and I just type in the general what here. Okay. Then in the main function, I just need to import the algo file. I will call it algo directly. Require algo. Okay. And then I will try to generate a wallet generate account. I will call this generate wallet. Oh, okay, sorry. This is generate wallet. And then I export this on the console. Print this in the console. Okay. Then you have finished this file. You can run it in your command line node min.js. Okay, you need to in order to use this function, you need to do this. You need to call it from this instance. Mnemonic. Oh, sorry, it's a typo. Mnemonic. Okay, now you can see that this is the account information, wallet information. You have an account address is this. Secret key is displayed in the form of a buffer bets buffer, and this is a mnemonic key. And so now you have finished generating your wallet, and then what you want to do is to fund your accounts with the testnet faucet. So you just go to this. I think this one. Yeah, just go to this website and put your address here and click dispense to receive 100 algo for testing. So after you have your wallet and you have found your accounts, you can send a transaction. And here, for sending a transaction, you have basically 5 steps. The first step is to construct the transaction body, and this will involve these parameters. And after you have constructed, you just sign the transaction with this command in the SDK, and then you send the transaction to the network to let the network verify your transaction and to confirm it. And then you need to have a function to wait for the confirmation of the transaction, and then you can proceed to the next step, right? You need to wait for the transaction to be confirmed to proceed to the next step. And after it's confirmed, you can also retrieve the transaction information back from the network, and you can do this with this command. So let me show you how to do this in practice. And to do this, I think I will jump a little bit, just due to time limitation. I will just do a little bit jump. What I'm gonna do is I will copy and paste the file I have in the some of the codes I have in this file. So I already sent the link to in the chat box, so you can open this file as well. And I will just copy and paste this function into my file. So this is a send payment transaction function. Maybe let me just explain this function in detail. So this function has 3 input parameters: the mnemonic of the from account in this transaction. So you want to send tokens from this account, and this is the mnemonic of that account. And also you have the to parameter, which is the address of the receiver of the transaction, and there's the amount of algos you want to spend. And the first thing you can do is to convert the mnemonic into the address, into the account, and then you can have the address and also the secret key. And to send a transaction, before you construct a transaction, you can see that there are some parameters in this that requires you to get some information from the blockchain. So this involves the genesis hash ID of the blockchain and also the genesis hash of the blockchain. And to do that, you need to send a request to the blockchain to get this the parameters. And this function is actually a utility function that I have prepared for you guys. You can just copy and paste it here. I will put it here. So it's called get chain parameter function, and it will retrieve all of these parameters back from the blockchain. This includes how much transaction fee you should set for this transaction, and what are the range that you want. So you can, for a transaction, you can specify what are the effective range of this transaction. So you can see that I only want this transaction to be effective from the latest block to 1,000 blocks after. In this case, I set it to 1,000. So the transaction will be expired in 1,000 blocks. It will not be always effective. And I want to have this parameter is because that maybe sometimes I want to construct this transaction and assign this transaction, and then I want to send this transaction to someone else. And I don't want to broadcast it to the network directly. I want to send it to someone else to let others to have control of this transaction, to let others to have something to decide if they want to send this transaction or not. So in this case, I may want to set an expiration, a timeout for this transaction. And these two parameters, first round and last round, will come in handy for this purpose. And this function, as you can see, it sends a request to the through the Algorand client instance to the network to request for these parameters. And this is written in the promise flavor. If you are not familiar with promise, it is a synchronized JavaScript function style that you can write a function like this, and it will return you with a synchronized function. And after this function is so let's see here, you call this function to request the parameter back from the chain. And after the function is completed, that you have get a message back from the network, then you can use the .sign part to execute the following part. So this part is actually also a a function that you has an input parameters that you can get from the previous promise function, which returns here using the result function. So this is part that you need to have some of the basic JavaScript knowledge. And if you don't have that, you can just remember that resolve is a return of the function, and then there's a next step of this function. And after you have the chain parameters, you can construct the transaction body like this. Two will be the receiver of the transaction. The fee, transaction fee, will be the parameters you get from the blockchain. And the amount, it's the amount of tokens that you want to spend. And the first round, last round, it's parameters that you can set for the timeout of the transaction. And the genesis hash ID and genesis hash is just two metadata for the transaction. And also here you can set a close to transaction ID. Sorry, so the close to transaction is close to address. So you can send this to close an address. So let's say if you have an account that that has 100 algos in it, and if you want to close this account and send all the asset in under this account to another address, you can specify the address here and then send this transaction out, and then you will close that account, and all the asset will be go to this account. And node field here is it's just a field for storing arbitrary data in the transaction. So you can put any data in here as reference for this transaction. So after you have constructed this transaction, you can sign this transaction with this command from the SDK. This happens offline, and you need to sign it with account transaction account secret key to sign this account. And after that, you will have the signed transaction body, and then you can attach the transaction body. Let me just print the signed transaction here, so you can see the inner structure of the signed transaction later. And you can put the signed transaction in the send raw transaction function, and this will submit the transaction to network, and then it will submit the transaction to network, and it returns you with the transaction information of this transaction. And then using the transaction ID of this transaction, you can just call this wait for confirmation function. And this is also a utility function that I have prepared. So this function, basically what it does is that it iterates it sends transaction to the network in multiple times to request for retrieving the the transaction ID, the transaction information from the network. And if it has confirmed in a round, then it means that the transaction is confirmed. Then it will return the transaction information from this function, and it just do this one time and again to make sure that the transaction is confirmed, and then it will do this with an interval of 2000 milliseconds. And after the transaction is confirmed, it just prints the message get back from this function to the screen. And then you can use this function again to retrieve the transaction information and return the transaction information. This part returns the transaction ID. So this is a send payment transaction, and let's test it. So what you can do is that you can copy and paste the transaction into here. And also you need to make sure that you call it from the algo parameter. And here I have prepared 2 accounts to use just for convenience. So these 2 accounts, I have funded them with enough algo tokens. And I will send this to the chat as well. So for the convenience, I will just use these 2 accounts along all the demo to demonstrate. So let's see, I want to send some tokens from Alice to Bob. So I will just put Alice's mnemonic here and put Bob's address here. And for the amount, let's see, I want to define this as a variable. Maybe I will put I will need to put 6 0 here because algo has 6 decimals, and this amount actually stands for 1 algo because that algo has 6 decimals. So if you want to spend 10 algos, you just add 1 more 0 behind this. So here I just spend 1 algo from this address to here, and then as this is also a promise function, I will specify then, and it will return me with the TXI transaction ID of the function, and I can print the transaction ID in the console. Also, don't forget to process to catch the error. You can also just for convenience, you can just put console.log function in here directly, and it will catch the error message and print it on screen directly. Okay, now that we can test it. So you can just run the function. Okay, what's the problem? It's not a function. This is because I have not exported the function here. So if I export the function here, it should be fixed. Okay, now it should be working. It's should be sending a transaction to the. Here you can see this is the transaction body. Sign the transaction. It has a transaction ID. It has the send transaction body display. In the form of a bet array. And then its transaction is waiting. It's confirmed on the blockchain. And then you can just go to our Algo Explorer to see this transaction. And it should be, so amount is 1 algo from this address, Alice to Bob. And as you can see, this is Alice's address, this is Bob's address. It sends 1 token from Alice to Bob, and the transaction is completed. Okay, so this is how we send a payment transaction. It has basically 5 steps. It's pretty easy, right? If you have any questions, feel free to send it to the chat box. And the next step we need to do is a little bit more exciting. We want to create our own token, and we want to transfer this asset around. So first, I need to introduce a little bit more about what is our Algorand standard asset. So Algorand standard asset, you can call it AST for short, is a standard that you can use to create customized tokens. And it has multiple benefits. The first one is that you can create a layer 1 native token, and this can be non-fungible token or fungible tokens. And this token will be just like the native token algo, and it will has no difference with that. You can interact these two kinds of tokens can interact with each other seamlessly, and it can be created in maybe not minutes, maybe seconds. It only takes 1 transaction to create these tokens, and you don't need to program any smart contract to deploy this token. You don't have to deploy a contract just for issuing token. You can just do this by sending a transaction. And also you can set different roles for this kind of asset. You can set an administrator that can mint and burn the token. You can set people who can freeze this asset. You can just reject all the assets, these transactions that related to this asset, or you can revoke this asset and get all the assets back to address. And also you can dedicate these roles to different address. Sorry. And also there's the asset spam protection function. So consider that in the financial world, that some of the financial product that you want to there might be some cases that you don't want to receive a specific kinds of financial asset because there might be some special tax policy along with this asset, or maybe this is not some illegal asset that you don't want it to appear on your account. So we have this mechanism that to protect you from that. So in order to receive an asset, you need to send, in order for an account to receive a new kind of asset, this account needs to initiate an opt-in process to receive, to let the network, let the Algorand know that I'm ready to receive this asset. And before you do this, you cannot, the asset will not be able to be sent to your account. And this also works in the context of KYC and ML. So if you are not qualified to receive a kind of asset, then you can just choose to not to. And also here's a demo built by algodesk.io. It just shows you a very simple demo of how to create an asset. Yeah, it's basically just like the demo I've created. Just input the parameters here, just click on the button, and create an asset. And here's how it shows in the GUI. Okay, let's jump into the coding part. So there are still 5 steps for creating an asset, because creating an asset is basically still just making a transaction. What is different is that the transaction you are constructing is a little bit different, and you can do this by using a function in our SDK. So let me show you how to do this in practice. Still, just for the favor of the time, I would just quickly copy and paste my my prepared function from this file into here. So this is the function that you can use to create an asset. You can see it has all of these input parameters. And for this part is the part that you can use to sort of configure all of these parameters. You can recover the account from the mnemonic. You can get the address from it. You can choose if the assets want to be frozen or not. So to set this parameter to true, you can to answer this question, will there be 2 wallets, one for the tokens and one for the asset quantity? Actually, no. You can have. Let me show this in this example. All right. Maybe it's better to see it here. So this mnemonic is actually for this address. So you can use one account to issue this asset, and all the tokens will be in this account. And this account will be the manager of this asset, will be the reserve address for this asset, that it has all of this asset in it, and it will have the right to freeze this asset and to revoke all the assets. So it can be in a single wallet. It doesn't have to be 2 wallets. And there will be no separated smart contract for this. So there will be no contract address for this asset. There will only be one single wallet for this asset. And it can be the manager of this asset, or it can be the reserve of this asset. It has different role for this asset. So here, just let me go through these parameters one by one. Decimals is default frozen. It's that you do want to freeze this account before transacting this asset. So you can choose that if I have this account and I want to use this account to issue an asset, then I want to make sure that I don't want to let this account to send any transactions before this account spend some of the assets tokens from the reserve, right? So this could happen in some of the application scenarios which provide you these configuration parameters here. You can choose to set it into a default frozen. And for the details of the explanation of all these parameters, you can feel free to go to our developer website. Where is our developer website? It's a developer.algorand.org, and you can have a very comprehensive, detailed explanation to all of these parameters. And here I will just give you a very brief introduction. And the decimal is for setting up how many decimals you want for this asset. For Algorand is 6, right? And the total issuance is how many tokens do you want to issue for this asset. If you want to issue a fungible token, then you can just set it to 1,000, 100, whatever you want. And if you want to issue a non-fungible token, what you can do is just simply set decimals to 0 and total issuance to 1. So in this case, you will issue an asset that has only one of it. And in this case, it is a non-fungible token. And asset metadata hash is basically arbitrary hash you can put it here. You can just basically, if you want to attach some data to this asset, you can make a hash of that data and put a hash here. And this hash is aligned with that data, and you can later just prove that this data is aligned with this asset. You can just use that data to store some asset related information. And the following process is very similar to the payment transaction. You first need to get the chain parameters back from the network, and this includes network fee, first round, last round, the effective range of the transaction, genesis hash, genesis ID, and And the difference in here is that you need to call this function from our SDK. It's called make asset create transaction. For using this transaction, using this function, you can get a different transaction body in here. Maybe let me print out this one as well, so you will know how it looks. And then you just sign the transaction with a private key, and then you submit the signed transaction to the network, and you wait for the transaction to be confirmed, and just print out the message, and then you retrieve the transaction information back from the network. Sorry, my neighbor is decorating their house. And then at the final, you can just return the created transaction ID from this function. And then let's test how it works. We need to export it. Then in the main file, sorry about that. Let me put on my earphone. Sorry, just a minute. Just a minute. It's working? Hello? Oh, okay. It's working. Okay. Yeah, so next thing we want to do is to create an asset. Yes. What I'm going to do for convenience, just copy and paste it here. And we need to fill in all of these parameters. So I will just copy and paste it here and select all these things and configure them as variables. For mnemonic, we will just use Alice's mnemonic here for this parameter. And for default frozen, we will say no. Decimals, let's say we want to have 2 decimals. And total issuance, let's say we want to have maybe 10,000 tokens. Unit name and asset name, I think so, code camp token. And the unit name could be CCT. And be sure that you code this because it should be a string. And asset URL, I will just put in our address for our developer portal. So you can put the URL here. And for the manager address, you can just specify Alice's address here. And also for reserve address, freeze address, clawback address, so that you can say that you only need one wallet, this one account to issue this asset. And all the token will go to this wallet. And this will be the reserve address. It also has the right to freeze the asset and revoke the asset. Okay, you have set up all the parameters, and now you okay, needs to be called from the Algo file. You can capture the asset ID from the return of the function. Sorry, this is too long. Asset function, and you can print the asset ID on the screen. And also remember to handle the error. Okay. Okay, all set. That should be fine. Let me do a little bit formatting. Okay, clear the screen. Let's make a test. Oh, no errors. Okay, interesting. So here you can say that this is the transaction that you have constructed. It has all of the parameters you have set, the fee, transaction fee, first round, last round. So a lot of parameters I didn't define. The total issuance of the asset is 10,000. Decimal is 2. Default frozen false. Asset manager, it should be the same, the Alice's account. And the unit name is CCT. Asset name is codecamp token. Asset URL, asset metadata hash. And then you just wait for this transaction to be confirmed. and it's confirmed, and it also returns you the asset ID. So you can search this asset ID on the Explorer. Hey, what's going on? Okay. Okay, you can see that this is a token. This is asset we just created. It's called a CodeCamp token, and this is the URL of it, and the unit name is CCT. This is the asset ID of it, and here are all the asset information about this asset. Okay, so we have finished creating this asset. The next step is we want to transfer this asset, but sorry. But before you transfer this asset, you should remember that, as I have mentioned here, we have an asset spam protection mechanism, which requires any account to receive a new asset, it needs to send an opt-in transaction first. So what is an opt-in transaction? It is actually very simple. And it is just a transaction that, so for this account to send an opt-in transaction, it needs to send a transaction from A to itself and also make the amount to be 0. Okay, let me show you how to do this. So first, still I need to, just forgive me for convenience. I will just copy and paste, where is the file? Copy and paste this function, send asset transaction function from this file into my algo.js. So here, as you can see, it also has a similar structure to all of the above functions. So first, it's construct the transaction with all of these parameters. And so asset ID is the ID of the asset that you can see here. This is asset ID. And the note is a field that you can put in arbitrary data. And the sender is the sender of the transaction. Recipient is the recipient of the transaction. You put their address here. And the revocation target is something that you can use to configure this asset. You can close this asset by revoking all the asset and to an address. And here I just make it to undefined. I will not use this function here. And close remember to is closing the. Oh, sorry. So this part, this is for closing the account and send all the asset to an address. And this part is send all the asset to an address, but not closing it. So this is 2 different parameters you can set, but I don't use these functions here, so I set it to undefined. And the amount is the amount of assets you want to send for this transaction. And here, again, you want to use a function in our SDK called make asset transfer transaction. So you can use this function to create this transaction body. And then the following procedure is much similar to the above. You just sign this transaction and submit it to our network, and then wait for the transaction to be confirmed, and then retrieve the transaction information back from the network, and then return the transaction ID. Okay, so it's very easy. And to test it, I need to export it first, and then in the function in here, after I have created this asset, what I want to do is that I want to send opt-in transaction for Bob's account. Maybe just let's sending opt-in transactions. So we have this on our screen, so it's clear. And to do this, you still need to call this function from this file, send asset transaction. And first, you want to send this, as I mentioned here, to send an opt-in transaction. You want to send a transaction to itself. So you put both Bob's mnemonic here and Bob's address here. And also the asset ID is the same asset ID here. And the amount, you just set it to 0. Okay? So in this way, you can do an opt-in transaction. And then, then what you want to do is to get the transaction ID and print out the transaction ID. Okay, and let's do a test run. Okay, so here is a constructed transaction for creating the asset, and now it's waiting for the confirmation from the blockchain. Okay, it's confirmed, and then sending the opt-in transaction here, and waiting for this transaction to be confirmed, and it should be done in 5 seconds. Okay, it's done. So yeah, so let's say that this first transaction is for creating the asset. And if you search it here, maybe just let's take it this way to make it clear. Okay, you can see this is the asset creation transaction, creates this asset, and the asset ID is this one. And then if you see this transaction, maybe let me, this transaction, it should be a transaction from Bob to itself, with an amount of 0. So now you have finished the opt-in transaction part. And then now you can try to transfer an asset, right? So because the asset creator is Alice here, so what I want to do is transfer some asset from Alice to Bob after Bob has done the opt-in transaction. So what I will do is call this send asset transaction function again, but this time from Alice's account to Bob's address again, and using the same asset ID, but for the amount here, maybe just set it hard coded here. I want to send 2,000. Still using a amount 1,000. 1,000, yes, 1,000. 1,000 asset tokens to this address, and then get the transaction ID, and then print it out. Okay, here maybe I want to add some promotes here to sending assets from Alice to Bob. Okay, and also don't forget to catch the error. Okay. Now, as you can see that first I created an asset using Alice's account with these parameters. And then I use Bob's account to send a transaction to itself with an amount of 0 to finish the opt-in. And then I send some asset, 1,000 of this asset from Alice to Bob using the same asset ID. And let's see what's happening. Still, this is a, maybe I should uncomment this part, sorry. Transaction, okay. So it's now it's creating the assets, and the asset is created and confirmed, and then it's sending the opt-in transaction, and the transaction is confirmed, and then it's sending assets from Alice Bob, and now it's waiting for confirmation. Okay, the transaction confirmed, and then we can go to the this transaction to see how it goes. Okay, as you can see here, because I set the decimals to 2, so even though I put the amount as 1,000, it is actually appears as 10 tokens, 10 CDT tokens. And the sender has 90 CDT tokens in balance remain, and the receiver has 10 CDT now. And the receiver is Bob and sender is Alice. Okay, so now we have known how to create an asset and how to transfer an asset. So up until now, I think you have been you have known just a very important function of Algorand, creating asset, and you can use this asset to represent different kinds of financial product. and you can use it in your own application. And the final part is how to use a smart contract, but not program. Because I know that some of you have asked us about if we are going to teach how to program a smart contract in this session today. But first, that due to the limitation, this could take another hour to teach this. And also, secondly, we will have a major upgrade to our smart contract mechanism in early next month. And we will have a more comprehensive smart contract by that time. So to not confuse you guys, I will try to arrange another session maybe next month to teach you how to program smart contract on Algorand. But for now, we only focus on how to use a smart contract. And the smart contract I will use here. Sorry, let me just introduce Algorand smart contract to you guys. So Algorand smart contract is based on a transaction execution approval language. So it doesn't work like the contract on Ethereum, where it is more focused on computation. That in the contract you can do a lot of computation, just take in the transaction as input parameters, and do some computation and return the computation result. So on Algorand, it doesn't work like that. Algorand, our smart contract, what it does is it's basically a transaction approval language. So it only tells you if this transaction will be approved or not. It returns a binary value, true or false. If the transaction is approved, then it's true. If it's not approved, it's false. And to use this contract, what you need to do is to construct this contract logic, and then send a transaction that meets this logic. And if you want to send a transaction that doesn't meet with this logic, then the transaction will be rejected by this logic. It will not be approved on the blockchain. And to program this logic, you can use the language named TEAL. I will introduce this later. And also we have a wrapper on this language called Haichao, and you can also program this in Python. And as I mentioned, we will have a major upgrade next month, which is that we will have a stateful TEAL coming up. So currently what you have on the Algorand blockchain is a stateless contract programming language. So you cannot store any state data inside of the blockchain, inside of the contract. But after next month, you will have another TEAL paradigm that allows you to store local and global data on chain, so which will enable more applications. So I will introduce this by then. And also you can combine the smart contract functionality with other features such as atomic transfers and Algorand assets to realize all kinds of different application scenarios. And also you can combine the stateless contract and stateful contract. Also still, this I will introduce later in another workshop. So TEAL, as I mentioned, you need to program contract on Algorand using the TEAL language. It is the transaction execution approval language in short. And this is a bytecode based stack language. So basically you will see this very similar to the programming language of Bitcoin. So it's a script based language, and it's also a stack based. So you put all of the operation code in a stack, and it will be executed one by one from top to the bottom. And as a result of this program, it will only return true or false to let you know if the transaction you submitted will be approved or not. And also we have SDK support for this one, and which I'm going to use in our example later. And also we have some templates, contract templates that you can use directly. This comes in very handy. And also this is integrated into the SDK as well, so you can use it directly from the SDK. And we have more than 70 opcodes for you to use. And the contract, for inside of the contract, you can access to assets or algos balances. You can build applications that depends on these values. And also, if you combine this with atomic transfers, and you send a group of transactions to from the contract or to the contract, then the contract will be able to read all the transactions in this group and all the information about them. And it will be able for you to design a more complex logic. And also later it will support stateful storage, store global and local storage. And and for now, what it does, it only verifies signature in a stateless way. And also TEAL support. Yes, you are able to write this contract in Python. Okay, and now I'm gonna introduce you to this contract. I'm gonna show you. So this is an example. Okay, maybe. Okay, let's continue. So this contract is called limit order. So what it does is that it involves two participants who want to trade assets for algos in this trade. And the workflow is like this. So first, Alice, let's say Alice wants to get some assets and Bob wants to get some algo. So the way you do this is that you can either through a centralized intermediary to witness this transaction to happen, because this involves two transactions on blockchain, right? So you want to make sure that these two transactions happen at the same time. And to do this, you want to involve atomic transfer feature to make these two transactions happen at the same time. But this process will involve Alice to monitor the whole process. So she needs to stay here she needs to find, to source the counterparty for this trade, and she needs to be there when this trade happens. But what if the Alice wants to just just to post out an advertisement to say that I want to exchange some assets in exchange of some algos, and he just want to leave the message out there and for others to take it. In this case, she can create a contract and called limit order contract, and for others to use. And if Bob sees his contract and he's satisfied with the contract terms, then he can just execute these two transactions directly without the involvement of Alice. So this happens in 3 steps. The first, Alice creates a contract account using the TEAL contract, and secondly, the Alice need to charge the algos into the contract account. And third, after Bob funds the contract, and then Bob can issue 2 transactions. One is to get the algos from the contract, and the other one is to send the asset to the Alice. And it is the logic in this contract account that will make sure that these 2 transactions, the transaction from algo from contract to Bob in algo, and also the transaction from Bob to Alice in asset, these 2 transactions will be executed at the same time. So this is what the logic in the contract will make sure of. And after this, after understanding the logic of this demo, as I have showed you, I have prepared a GUI demo here that you can create an order. So this is the first step here, create an order. And then you need to send some tokens to this address. But actually I've already done that. So you can see that there should be some algos in here. So after you have created this order, yeah, there are still already some algos in here. So then the third step is to initiate these 2 transactions, send algos to Bob and send assets from Bob to Alice. And you just click here, and this will send 2 transactions. So if Alice creates contract and say another name, the case create the contract on same amount to buy from Bob, Bob can choose from either, will be rejected. No. Let's say if you have, so this is Alice's mnemonic, create an account, so maybe let's refresh this. So now Alice has created a contract, right? As you can see here, this is the address of the contract. And now let's say Bob, what is it? Sorry. Bob also wants to create a contract. I can say you have two contracts here. They have the same logic inside, but they have different contract address, and they have different order ID. They have different contract address. So both of these two contracts can be used. Can be executed later. But if you want to say that, if you want to Alice to be able to have this feature that once Alice create a contract and create another contract, and you want to make sure the first contract is obsoleted, you can actually program this into the logic. It's possible to do this. Hope this answers your question. Yes. So after seeing this demo, let's see how to use a contract like this. So first thing you need to do is to program the TEAL contract. And to do this, I will show you the TEAL contract, how it looks, but forgive me that I will not teach you how to program this. So here is how the contract looks. As you can see, it's a stack-based smart contract, and it has multiple. So here, this is the operation code, and this is the parameters that takes into this operation. Let me just try to explain this briefly to you, because this is rather a little bit complicated. So this contract will accept two transactions in a transaction group. The first one, so the first thing it does here is to make sure that the transaction it's accessing right now. It has a group index of 0 in this transaction group. So the number 0 transaction in this transaction group, and it wants to make sure that the type of the transaction is 1. Which is the asset, which is the algo transaction, the payment, the normal transaction. And you also want to make sure the transaction fee of this transaction is less than 2,000. So you don't want the transaction to spend all the algos in the contract by spending it on the transaction fee. So this is the limitation here. And also you want to make sure that the size of the transaction group is equal to 1, and I don't know what it is. So, sorry, this is rather complicated. But basically, what it does is it verifies several logics, several conditions that a trade like this should meet. So it makes sure that the two transactions, once this transaction and these transactions, the condition of these two transactions can be approved by this contract, and all other kinds of transactions cannot be approved by this contract. So this is what it does. It's a transaction approval language. And the contract is like this. You can say that it verifies the receiver is this receiver. The close remainder is this render. So how do you use something like this? Still, I will copy and paste my code from this part. Let's create a limit order function. Maybe also the next function. And so here, this function is for creating the limit order contract. As you can see here, all the parameters that you want to take in, the account required from mnemonic, the address, the rate of the trade. How many assets do you want to trade for how many algos, and the asset ID, the ID of the asset you want to trade, and expiry round, just in how many rounds do you want this order to be expired, and the main trade. So how many algos do you want to spend at least for each trade, and the maximum transaction fee, you can set it here. And then after taking all of these parameters, you can just simply call a, so this is a function in our SDK. I need to include it from our SDK here.
if Alice creates a contract of algo 100 for Bob's asset, and David create a contract for algo 100 for Bob's asset, but Bob can choose to accept from any of them. Then the other contract will refund the algo to the owner, means the code on top of the contract. Exactly, yes. You can write only one piece of the contract, then you just change several parameters in here. The several parameters in here, like this one, owner account here, then you have another contract. You don't have to rewrite the contract again. And behind the hood, under the hood, this is what happens. So this is rather complicated. That's why I want to spend it for another session, save it for another session. So basically what it does is that here, this is what you get after you compile this program. After you compile this program, you will get a base64 based string, which is like this. And to put the parameters in it, you can to put the parameters in it through the code, you can replace several of the bets in here, and you can specify the offsets here with the parameters you want to specify. And this is the types of them. You can inject this parameter into the contract after it is compiled, and then you just return me with injected bets. So this is what this function does. And if you call this function, you will be able to get after you specify all these parameters, you will be able to get the limit order contract from this function, and then you just return this function to me. So what I will do is in this main function, so after I create the assets, I do the opt-in and send some asset to Bob, and then maybe Alice wants to, let's say, still in this case, Alice wants to send some algo to Bob in exchange for some asset from Bob. Okay, so to do this, we can first create what is the name again? Create limit order. Create a limit order. You call this function to create. So mnemonic should be Alice. Alice is the owner of this contract. She will create this contract. The asset ID is the same asset ID here. Sorry. And the asset amount, let's say, asset amount, let's see, he wants to, he wants to get this amount of asset back from her. And what is the next one? Algo amount. Okay, algo amount. Let's see. Let's specify this as asset amount. Asset amount. Algo amount. How much algo amount do we want? Maybe one algo. One algo. This is one algo. And okay, now we have the contract. What's the next parameter? Algo amount. Asset amount. Algo amount. And the main trade. Let's say we want to make this order to be a one-time order. Means that you cannot partially execute the order. You either execute all of it or none of it. So in this case, we will just make it the algo amount -1. In this case, that you limit the amount of algo you can use when you are executing this order, and which make this a one-time order. And then you can, then you can, this should give you back a contract. And then you can print out this contract to see how it looks. Okay, this should be working. Okay, it's working. Let's wait for a while. Okay, so it's finished. And as you can see, this transaction is for creating the asset. And this transaction is for sending the opt-in transaction. This transaction is for sending some assets from Alice Bob. And then finally you get the contract. So in the contract structure, you can say that there are several parameters. This is the address of this contract, and this is the bad code of this contract. And this is the owner of this contract, which is Alice's address. And this is the asset ID. Okay, so you have created this contract, and the next thing you want to do is you need to fund this contract. You need to send some algos to this contract. So to do that, still you can just call a send payment transaction, and from Alice's account to Bob's address. Sorry, to contract's address. You want to send this to contract address, so you can access it from here. And the amount should be, you want to send algo to it. So algo amount, and then, oh, okay, this is out of it. And then you just, then you will get the transaction ID. You just print out the transaction ID. And also don't forget to handle the error. Okay, let's see how it goes. Oh, okay, so there should be an error for this case because you will see, yeah, there should be an error message. Made a mistake here. I explain how is it. Waiting for confirmation. Sending it, okay, the contract, and now it is sending payment transaction. Payment transaction, this is payment transaction structure. Oh, okay. So actually, I think the problem here is that, let me try to alter this a little bit. Maybe like this. I want to show this error to you guys. Payment, there's a something I don't want to print out here. Let me comment this. Okay, let's try it again. There should be an error in the in this process. Yeah, the slides and also the code and also the recordings will be the recording will be uploaded to YouTube, and it will be cut into 3 sessions. You can feel free to choose which session to listen to afterwards. And also all the codes will be on GitHub. The slides I will put they are Google Doc based, so I'll just share the link with you guys. No problem. Address, contract address. So here's a, sorry, contract address. Is there tokens in there? Oh, there are tokens. Okay, there's no problem here. And then, as you can see that we have created asset, send the asset transaction, opt-in transaction, and send some asset to Bob. And then we want to create the contract. The contract is, sorry, contract. Create a contract, and then we send create a contract, send some token from Alice to the contract. And the third thing, the final thing we want to do is to do the atomic transaction, these two transactions, the algo from contract to Bob and the asset from Bob to Alice. And to do this, our SDK also prepared us with a function. So this is actually in here. It's called get swap asset transaction. This is aligned with the limit order templates. So this is actually how you do an atomic transfer. So let me also explain this. So here still are some parameters you want to define before you construct the transaction. And here, transaction group 0. Transaction group 0. Where does it define the transaction group? Oh, here. So here you can see that it makes two transactions. The first transaction is algo for assets. So it is a payment transaction, or algo payment transaction from the contract to the buyer address, right? And it specifies all the parameters here. And the second transaction is an asset transfer transaction. It's from the buyer's address to the contract owner. So the owner, the creator who created this contract, which is Alice in this case. So these two transactions are constructed and they are put into a transaction array and using this function to get a grouped transaction. And then what you need to do is, so here is just to handle some margin situations, to handle some errors in case that the parameters have some errors. And after you created this transaction group, what you want to do is to sign these transactions separately. So you sign the first transaction from the contract to buyer using the logic signature generated from the contract. So you can generate a logic signature from the contract. You can also call it contract signature. And also for the second transaction, you just sign it with the secret key of the buyer's address. All right. And then you just put these two single transaction into an array and return it to me. And then I just submit this transaction to the network to finish the execution of these two transactions at the same time. So this is what happens under the hood. And so in here, you can see that I define this send limit order swap asset transaction is basically a similar proceed as above, that it can get the chain parameters back from the network, and it defines the transaction structure here, and put the parameters into the this get swap assets transaction function, so that you get the grouped transaction, and then you just send this transaction, group the transaction to the network, and then wait for the confirmation, wait for the transaction to be confirmed, and then retrieve the transaction information back from the network, and then you return the transaction ID. Okay, so let's try it out. So here, after a send all goes to the transaction account, third thing I need to do is to do this swap transaction. So I will do this. I need to export this first. export this, and then call this function here. And there are several parameters that needs to put in here. The mnemonic is, so whose mnemonic is this? I think I need to put Bob's. So Bob is the order taker. So I need to put Bob's mnemonic in here. Bob's mnemonic. And the asset amount, because I wanted this to be a one-time order, so I just still put the asset amount here. And then the algo amount, I will put the algo amount here. And then contract, yes, just put the contract here. So this contains the contract information, asset ID as a contract address, and a contract barcode. And then I just get the transaction ID and print it out. And also handle the error. Okay, let's try it out. Yeah, so we also have a Telegram group, so feel free to join. I will be there and answer your questions. And if you have anything you want to know about Algorand, you just feel free to shoot your question in there anytime. And also I will put my slides in there. Yeah, please join. Okay, so it's going through this whole process. Transaction, sending assets from Alice to Bob. I will send the slides link to the Telegram, and as for the recordings, I think we will upload it to the YouTube, and I will send the YouTube link to the Telegram. And as for the code, the link to the code, I will send it now. Oh no, for this one, maybe I should just I will upload this code onto the GitHub later. So this is basically the basic example that you can use from the command line. And also here is a React demo example, which also contains this file. And you can try it out. You can see how does it work in the React. Oh, okay. We got an error here. You can see it says that this transaction is overspending this account for some reason. And I know exactly the reason why, but I mean, okay, let me just explain this to you. So when you are sending algos to this account, because you just created this contract account, so it's a company account. And if you send some algos to here, and then you want to spend that algos to Bob, the thing you are missing here is the transaction fee, because you are sending maybe maybe 1,000 algo to a contract address, and then you want to get this 1,000 algos back from the contract address to Bob. This transaction also needs a transaction fee, but if you only get 1,000 algo, then you cannot send 1,000 algo from contract to Bob, because you need some extra algos for the transaction fee. So here, what I'm missing here is that when I'm sending the, maybe let's note here, this is for sending algos to the contract. So what I need to do here is I need to send some extra algos as a transaction fee for the later transaction. So what I want to do is, maybe I just double the algo amount. It's not a lot, so never mind. And now the contract will have enough balance to send this transaction to Bob. There's a way to delegate the transaction fee to Bob, and it can be done with our smart contract. So the contract doesn't have to pay for the transaction fee, and Alice doesn't have to pay for the transaction fee either. And Bob can pay for the transaction fee, but that's for another topic. It can be done. I can tell you this. And also here, it's sending the transactions. Okay, and now let's try it again. Should work this time. The TPS for Algorand theoretically gets faster as more nodes join the network. Is that true? It is not true, actually. The max TPS for Algorand is around 1,000, and more nodes can only mean that there will be less TPS because the messages need to be broadcasted to more nodes and takes more bandwidth usage, and it should be slower. And this applies not only for Algorand, but applies for all the blockchain system. So I don't think there exists a system that gets faster when there's more nodes. Okay, there's another error. I think the algo amount is not enough. I need to increase the algo amount because the transaction fee is about 1,000. I think this is a problem. Okay, let me try it again. Let's make sure. 1, 2, 3, 4, 5, 6. Okay, yeah. So I'm exchanging once on the asset for one algo here. I think that's true. If you get this from an official team member of Algorand, then maybe there might be some context, I guess. And just for me, without any context, I would say this is not true. Okay, I hope it works this time. Okay, now it's sending the swap transactions. Waiting for confirmation. Okay, it's done. So here's the transaction ID. Let's see it in the Explorer. Explorer. You can see this is a transaction that involves a smart contract. Sender is the smart contract. And the receiver is Bob. The receiver here is Bob. B7K is Bob. And so this is a transaction that sends from the contract to Bob. And there should be another transaction from, where is it? From, where is it? Bob to Alice. Which one is it? Oh, it's a group transaction, sorry. I need to click in the group ID. Oh, okay, you can see here the transaction from the contract to Bob and the other transaction from Bob to Alice. So this is Alice's address. So this is a grouped transaction. It has two transactions and it executes at the same time. And this transaction, these are the two transactions. Okay. I think I finished introducing all the functions that I want to introduce today. And the last thing maybe I want to talk about is how to involve all of this in a React app. So we have built all of these functions using Algorand SDK, And also we have tested it in the command line. The next thing we want to do is to put this into a React project. And I have completed this demo here on GitHub. And let's see in here. I put it in a VS Code as well. So here's the photo structure. What I did is that I created this demo using Algo create React app, and I also used a UI framework called React Strap. It's a Bootstrap framework. And what you can do is that you just leverage this tool to create a photo structure like this, and then you can put your Algo.js here in a folder, and then in pages, in each of the pages, you just go to, let's say for the account page, you just portrait this page with, so if you are familiar with React, then this is super, super easy. Then what you do is that you put a navy bar here, navy frame, this is a navy bar, and you put a Jumbotron here, it's this deep color background, and a container which has one column, and head. This is the head title, create an account here, and this component is a form that has two inputs. One is for address, another one is for mnemonic, and then you put a button here and link this button's onClick event to a function named handleClick. And here's the function called handleClick. And just in the function, you can call the function from the Algo.js file. For example, you call the generate wallet function, and then you just set the state of this React function. And then each time you click on this button, it calls this function, it generates a new wallet and change the state of this page. And then you got the effect like this. Super easy, right? And it applies for the other page as well. The difference is that it might be a little bit complicated in terms of the page portraiting. So you have different components on the page, and you have a button at the end, and then you just handle the button click problem, and you just call the function from the Algo.js to realize the function and get a response in the state. Okay, so I think this should be pretty explanatory for how to use this in a React app. And if you have any other questions, take a look at our demo code first. And if you have any questions, just shout it out in our Telegram group. Okay, still, I want to echo again for how to get some algo rewards. And these are the programs I want to introduce. I've done this before. We have Developer Ambassador Program, which is that based on what you learned today, if you want to produce a tutorial, or if you want to produce a solution, then you can go to this website and submit it to us, and we will give you some rewards in August. And also we have the grant program. If you have some applications, you are building a startup, and you have a team, you have a developer workshop team, and you can also try to build something on Algorand, and you can apply for our grants. And also we have the Algorand Area Acceleration Program, which you can apply to. It's a startup acceleration. If you have a startup idea, you can just just apply your idea to us, submit your idea to us, and if you get selected, we will give you 15K as a startup fund. And then if you manage to finish your startup with your team, and you will be able to get to up to 250K grant for your project. And you will be introduced to all these mentors from very great projects, Huobi, Tether, some capitals, and also like traditional companies like PayPal. Yeah, you will be introduced to all of these people. Sounds great, right? So if you get any ideas, don't hesitate to apply, and I'll be waiting for you guys. And this actually wraps up for today's session. And I see there are some questions in the chat box. Two pre-Algorand released in future talk to each other as a credit. Actually, yes. To answer Direct's question regarding two chains interact with each other. So as I mentioned, we will have the co-chain framework in the future, and it is one of the core feature of co-chain is that it will have the interoperability feature that lets each other to send transaction to each other. And this will be done in a very quick, secure, and efficient way. And there is actually, I think there is a post that's published by Silvio Micali explaining this. Let's see if I can find it. Algorand coaching. And no, not gone. Okay, see you guys. One question, this video will be published somewhere, please send a link by email. Okay, I think the video will be published to YouTube. The link, we will send it out by email and also in the Telegram. We will make sure of that. And also, can solo developers apply? Yes, of course, yes. So we have for all of these programs here, as long as that you are capable enough to match the category criteria of them, then you are welcome to apply. And specifically for the developer ambassador program, this is just designed for solo developers. And if you create a solution, a tutorial with some videos, you will get this amount of Algos rewards. Yeah, and here on this web page, you can see the detailed instructions. And also for the grant program, if you can complete a tools or maybe an educational program for the community, if you can conduct the research on blockchain, then you can also apply to a grant. And we will assess the amount of grant that we can give you based on the contribution you have to the Algorand ecosystem. Yes, and this wraps up for today's session. Thank you everyone for following along the whole webinar. It's been a pretty long webinar. And if you have any questions, please shoot it to our Telegram box, and we will send a follow-up email to all of you guys to again with the slides, with the videos. And thank you very much. Hope you have a great day, great evening, great lunch, great dinner. And I'll send the let me send the link again. Okay, see you guys.